All right, good morning, Block 3. This is just a reminder that we do have every day, Miss Trainer and I are available for conference times during our Block 2 time, which is 9:40, and our Block 5 time, which is 11:40. So I do set up, if you go to your Schoology, all right, and you go to your courses, you go to what should look like Block 2 and Block 5 Q&A conferences. The reason is that I actually have 2 classes and students are in 4 different sections. This is the only way to make the conferences available to all my 9th graders in the same group at the same time. So this is every class day. If I go into this course, there should be a link over here on the left that'll say conferences. And I have them set up in here so you can see we have this conference is in progress. And these are the ones that, all the ones that we've had. If I've saved, we can make play. All right, and we can make a record. Sometimes I can make a recording that only stays up here for 7 days. So you can always look at that within the week. All right, but that was not my goal. My goal for today was to look at our DESMOS that I had assigned to you guys. So we're going to do that. I wanted to look at our class. So I wanted to look at our class just to kind of see how everyone was doing. And this is the wrong, this isn't the class I thought it was. All right, so this is kind of how everyone in your class is doing so far. The check means I think you got it right and the X means you didn't. So let's just take a look at some of our students and how we're doing. Okay, so we'll look at this. This is an anonymized name right here. So our first challenge, plot the parabola 3 points y equals x squared. This student did an excellent job. If you change that, take that x out, it's a line. Okay, x squared is the right solution. So let's look at the next one. Now, this student did a really excellent job with which colors? The purple and the red and the green. But the yellow, so let's get rid of this yellow. Or is that orange? Orange, let's say by, okay, and let's get rid of, wait, what happened? The green was right. Okay, and the blue, so the blue line wasn't right, so let's just get rid of that. Okay, now here's your hint. Okay, if you're moving the graph left or right, all right, if the graph is moving left or right, and maybe I'll take a screenshot of this, view, screen capture toolbar. If you move the graph left or right, you just add or subtract, send to a new page. All right. So let's just kind of write that down as a rule because this student did they recognize if the graph shifts left or right, we could say you add or subtract in the parentheses. That was really excellent how this student came up with that. I would be really interested to know how they did it. So that's what this student did, and that was excellent. But now we notice these points are shifted up or shifted down. Now, instead of adding in the parentheses, in with it, right, in with the parentheses, we're actually going to add on the outside, okay? So if the graph shifts up or down, so let's rewrite this. If the graph shifts up or down, and now I'm realizing I made a typo here, or down, okay? You add or start outside the parentheses, okay? So the equation here is going to look like y equals, I need my pencil to write. So the equation here might look like y equals x squared, and then plus or minus something, and then y equals x squared, and then plus or minus something. All right, so let's go back to our activity, right? And we could say y equals, the blue is how many spaces up? 1, 2, 3. 3 up, so let's try x squared, right, plus 3. Let's try that. Hey, it worked. Okay, so that was up 3, and then this one's down 3. 1, it's really hard to see this, isn't it? Isn't this something? This is like making me question myself here. 1, 2, 3, 3. Down 3, okay? So that would be y equals x squared minus 3. And say check my work. Okay, so that's kind of like the big takeaway with this one. All right, let's take a look at the next response here. So control plus, control minus, okay? Eric thinks the equation will match the blue graph. Jenny thinks it matches the red graph. Who is correct? Well, Oh man, this is a challenge. Okay, so this one you could explain either way. This student, I don't think they just didn't get to this. Who was correct, Eric or Jenny? So one tip I would give you guys is I would, you know, if you're really like not sure, just open up DESMOS.com and type in that equation, right? You could just go to the website and type in x minus 3 squared, and that's, look, it's this way. It's the graph that goes this way to the right. Okay. So the answer here would be Eric thinks the equation will match the blue graph. So Eric is the blue. Nope, it's Jenny. Jenny's right. Okay, and we could say Jenny is correct because Jenny is correct. This is a shift right. That's it. Okay, and share with the class. And 3 other students' response will show up here. I don't know if any other students responded to this. Maybe that's why. I know in the other class we had a lot of students that got to this. Maybe some didn't. Okay. Apollonius. What does it say? It's on the graph. Now that's not a good explanation. It didn't answer who's right or wrong. But they did say that Jenny was right there. Oh, it's on the graph. Yeah, I like that. That's a good solution. And these are just anonymized names. All right, let's take a look. Plot the 5 parabolas. Oh, this is so hard. Each parabola should pass through the origin of a pair of coordinate points. One is done for you. All right. So all of these should be x squareds. So let's, right away, whenever we do a parabola, it's an x squared situation. So right away, I'm going to change all these to x squareds. Okay, x squared. Only be using x squareds. All right, and for these, all right, the first one, let's say check my work. Oh, yeah, they're all x squareds. So check my work. So the problem is that I have so much going on here, and I don't know which ones are right. So let's see. So the red graph is correct, right? And the orange graph is correct. Okay, so let's get rid of the other ones. Red and orange. So red, orange, and purple. Okay, good. Now, what's going to happen here, this blue graph is actually going to be going through like this. All right, so we want to think of what, here we multiplied by 3. Okay, what could we multiply by to make it go wider? All right, and we're just going to test out some numbers. So let's test out like a 2. That takes it a little wider, but not wide enough. So let's pick a number less than 2. Let's say 1. Oh, that takes it a little wider. Okay, let's think. What's a number less than 1? Maybe 0.5. Let's try that. And say check my work. Almost, almost. What's a number less than 0.5? 0.25? Almost. It's almost there. This is challenging. So let's see. What's a number less than 0.25? Maybe 25 cents, maybe 20 cents. There we go. So that's how you would do it. You would just use guess and check. And I think I'm going to do one more. Let's do this green one since it's next right here. So it looks like this is going to be a little bit wider. So we're going to do the same thing. We're going to start with what we figured out here, but it's a little wider than -2. So maybe it's negative, maybe it's negative, well, less than, so let's do 3. So let's try -3 because that's less. Oh, that's not going the right way, right? It was out here and now it's in here. Or actually, did we even try any? Yeah, we want it to be further out. So let's see. So -4, does that solve it? Oh, that's even closer in. I think we're going the wrong way. Let's try this way. So let's try -1. So a lot of this is just guess and check. And that worked. I can't believe that worked. That's amazing. All right. So less than that. So for our last one, all right, I think we're still going to look at this -x², right? But our purple line, we want it to be wider. So we think, what's a number that's kind of like in between? We were going -2. Let's just check my work. So this is -2x², -1x². What kind of follows that pattern? So if you need to see that, I know I need to see it. Okay, it would go like this. It would go. So the pattern goes. We're getting up to 9 minutes. This would be -2x². So let's do it. Let's do it right here. Okay. Trust me, I'm going to make it look nice. That's -2x². okay? And then this one, this purple one, would be -3, right? I'm just matching it with what we did here. Oh, no, that's just -1, okay? And then, so -2, -1, what is less, if we're following that pattern, what's going to be less than that? Because this graph is going to go this way. What's going to be less than that? -2, -1. Well, if we try 0, that's probably not going to work. So maybe between 0, a number's between, so you want to test numbers between 0 and -1. Okay, let's test them out. So let's go back to our calculator and let's test out. So 0 and -1. So let's test out -0.5, right? Not good enough, right? So let's see. So that's still going the right direction. Let's try another one. Let's say like -0.2, 20 cents, right? 0.20, 20 cents. Does that work? Almost. Let's see, maybe a little bit less than that, 0.15 cents? 15 cents? I don't know, that looks pretty good. I mean, maybe we could be a little more, 18, maybe that looks a little better, but I think that looks pretty good. That looks like a good, I would be happy with that. All right, let's take a look at our next challenge. Plot a parabola through the points. Oh, goodness. So this parabola has to move over and down, right? Now, all of these, when I'm looking at this, all these should be x squared. All right, so this is a parabola that has to move over and move down. Okay, so let's do it. So it has to move over and move down. So when we look at this, right, our parabola, I want to touch my screen like it's an iPad and it's not. Okay, so we're taking our regular parabola. It usually looks like this, right? It usually looks like this. And we want to move it over and move it down. So we want to move it right and then down. So we're going to actually be looking at this y equals and the 2, and then we're going to have something in here to kind of just make it go through that vertex point. This is like a super challenge. All right, so to move it over, we do x minus. So in here we're going to have x minus, and think about that. How far are we moving it over? 4. So x take away 4, and then we want to move it down, right? Because it's got to be connected this way. Woo, and down. So to move it down, we subtract how far we want to move it. I think that's subtract 2. Okay, so let's go back to our calculator and let's check it out. I am noticing we're getting close to the 15-minute mark on this video, and I don't want this to be too long. So let's go back to our, so we had what? Y equals x minus 4 squared minus 2. Let's try it. Almost did. The only thing is we need to make it wider. And what did we just learn in our last exercise? To make it wider, we use decimals less than 1. To make it wider, we use decimals less than 1. So let's try like a 0.5, like 50 cents. Okay. Oh, we got lucky. It worked the first time. Okay. So we're going to wrap this up. Okay. If you want to continue with the challenges, you can. I'm not exactly sure how this started, but that was like our main thing right there. If you got those, that's really an excellent thing here. What happened here? Oh, I guess it didn't save the work we just did. Oh man, we can't review what we just did. Okay, so we're gonna wrap this up here. Hopefully you found this helpful. Just a reminder, we do have the information sessions every day at 11:40. As you can see, I have one running right now and no one's in it. But you can always stop by to ask questions 9:40 and 11:40. Okay, thank you.